Hello and welcome to PMCD MATHS Teaching, and today we're looking at enlargement using a centre of enlargement. And as usual, I've got the rationale coming up, so if you want to read this, it's a good idea, I think, to see where I'm coming from. If you just pause now and you can have a read of that. If you've done that, we're going to carry on. So, sequence of teaching, well, hierarchy of teaching, I suppose, in this case here. Before we get into enlargement, multiplication of fractions is going to be useful, especially when we go on to that fractional scale factor. And then you can see we're working through, it gets more and more difficult here. I just want to point out at this stage as well, I'll start off with the squares method of enlargement and then move on to ray method after that. But how do I introduce this? Well, you've seen the image we had already before here. Sometimes I've projected this, what is this? Let me know what these are. For those of you, who may know this, this is an example of Nazca lines in Peru. And we're going to come back to that a little bit later on because it is relevant to the topic that we are discussing. So enlargement, I usually do this on the start of the lesson. We're going on the assumption of a basic behaviour of light that is travelling in straight lines. So if the bulb switched on, how tall will the shadow of the pencil be? So we said we've got a screen, we've got a pencil, and we've got a light bulb. So as I said in the rationale, I'm trying to relate to something they can do quite easily. Now, in the old days, you used to be able to use a projector, and I used to be able to do this quite easily by putting your hand in front of the projector. I mean, if you ever had an overhead projector back in the old days, you'd always get some student, while your back's turned, trying to make a rabbit out of it. But, you can use this to your advantage because this is an example of how enlargement works. So what we're trying to get over here is the relationship between the size of the enlargement, the distance of the object from the centre of enlargement, and the distance of the image from the centre of enlargement. So this language needs to be used straight away, really. Don't hide it away, don't dumb it down. Let's be using those proper terminology straight away. So, they may not know. The great thing about this if you've got the interactive tool, and you pretty much can do this with anything now here. If the light bulb comes on, hopefully, they do know that light travels in straight lines. There's going to be a shadow. If they don't, this might be a revelation to them. Why is it traveling in straight lines? Well, we've got a light ray. That one will reach the screen, won't it? And so will all these. All of these light rays here will reach the screen. This one here. This one here. Okay, so what's happening in this space here? Well, we know that it's going to be a shadow, but how tall will that shadow be? Now, intuition tells them it's twice the distance the screen is from the centre of enlargement. So the shadow will be twice the size, 16 centimetres. That's an intuitional thing. That's not even, and we know intuition in maths can go wrong. We know that, but what we're trying to do is bring out that intuition and say, well, actually, yeah, there is a relationship. Then I'll start talking about, okay, what happens? Now, some of them may be able to tell you how tall it is. I'm not too, I don't go to focus on that too much at this stage. But so what happens if I move that pencil a bit closer now to the centre of enlargement, or as I'm calling it in this case, the bulb. So I'm not using that centre enlargement terminology just yet. So let's just move those rays. Okay, and move it closer. What's happening now? Again, you can see the ray, the bulb, the ray here, top of the pencil. What's happened to the enlargement now? It's got bigger, hasn't it? And again, you can demonstrate this. If you've got a projector, you can demonstrate this by moving your hand close to the projector and further away. Possibly, if you're allowed, your policy allows students to have phones out, they could use the torch on their phone and they could do it above their hand and see the image on the desk. If you don't want to do that, you can bring your own torch and make images as well. You can even ask somebody if they can do the bunny rabbit. I mean, anything that's going to get their engagement and their interest here is going to be good. So what do we want out of this? Well, the minimum we want out of this is that there is a relationship between the size of the image, and that's what we're going to call it now. We're going to call it the shadow. We're going to call it the image. Okay, it has something to do with the relationship between how far the object is away from the centre of enlargement and how far the image will be from the centre of enlargement. Okay, so we've got these distances make a difference here. Okay, we're going to use that a little bit later on. And I can introduce this here. You know, we could say, okay, what's happening with the original case when we had it? I mean, I've done this where I've left it 8 centimetres. Sorry, I've left it 100 centimetres away, then I've moved it to 50 centimetres, then I've moved it to 150 centimetres. Depending on the class, how far I can push with that. You know, sometimes you can push and you can get, even at this stage, you can get them saying they can work out, yeah, okay, so if it's at 8 centimetres, I'm getting a 16 centimetre shadow. If it's at 50 centimetres, I'm going to get a, what's that? It's 4 times, isn't it? So it's going to be a 32 centimetre shadow, and so on. So sometimes that intuition for that is there already, and we're going to prove that a little bit later on. And you can say that, yes, so how many times bigger is it then? Well, it's four times, the screen is 4 times further away than the object. Okay, now this language is difficult, isn't it? 4 times further away than the, I mean, you see this in exam papers sometimes and it throws them. So you might have to take your time to explain that. Maybe do, you know, reiterate that. Try it with, bounce it around the class when you try different distances here. And the scale factor would be that multiplication of 4, wouldn't it? 4 times bigger. There it is, 4 times. Object, image, and we've got an enlargement here. Okay, so moving on then. So, okay, a little bit of fun, my sense of humour really here, but it's quite interesting, isn't it? Okay, so I'll leave you to decide whether you think that's funny or not. I saw this ball was getting bigger and bigger, then it hit me. How do we make it appear bigger? How would I make that bigger? Well, you can see if I do that fast enough, it actually looks like the ball's approaching us, doesn't it? So I say, well, obviously, how do we do this in a game, a football game, any game where something's moving towards you, to give that impression, that must be getting enlarged, and they'll say reduced as well at this stage, but we're going to call that a fractional enlargement a little bit later on. So we want to be precise as much as we can here, but it's great. You can show that. You can show what's going on here. You can actually do a bit of animation here. Okay. And some other things here. Where would it be used? Well, we said already, you know, going back to this, it could be any sort of games console where you've got some 3D element to it. And that might just be somebody walking backwards and forwards, character. You know, the common one for the boys obviously is FIFA. They use that a lot. Or Fortnite. For girls, you know, we can refer to things like these films that have CGI in them. You know, these are computer-generated graphics, and they are, you know, how do they control that? And really, all we're looking at is a set of pixels on a screen being controlled by some sort of coding. Now, mathematics has got to be behind that for that to work in the correct way. Okay, so we'd have to enlarge if we want to show, you know, explosions getting bigger and bigger. Then we'd have to be able to enlarge the image and make those pixels move in an appropriate way. So it's very relevant. And obviously, I've gone to the one here: scale drawing or a scale model. So we've got scale coming into it as well. Okay, you may have done this may lead on to scale drawing, or you may have done a bit of scale drawing before. I haven't mentioned that in the sequence of teaching, but it's a brilliant link to that as well. So I've used a drag racer there, but you can talk about architecture. You know, again, scale drawing would be needed here for enlargement. But for accurate enlargements from central enlargement, and where else might they have seen it? They might have seen it at the cinema. You know, they've got a small image is enlarged. In the old-fashioned days, would still be a reel with light passing through that. And to get the right size, we'd have to have the right distance between the bulb, the film, and the screen. Okay, so training phase. And I think I said here, my disappointment initially with my own lessons was that I relied on the textbook. I relied on the textbook, just notice a spelling mistake there, to get me through that, because the problem is with a lot of textbooks, it's not done very well. It's not done very well because the students have to copy it. In the worst ones I've seen, and then you end up with, say they have to enlarge a triangle. In the worst ones, you actually end up with, you know, 30 different triangles they're trying to enlarge. Then what happens is, because they've drawn it too big or too small, they can't do it because it's too small, so they can't work out what to do, and they haven't drawn it on the squares in their book, or if it's too large, the enlargement goes off the page. It can be absolute chaos, and then you don't look forward to it. So how do we get around that? We control that. We control the things we can. What's the focus? Is the focus to be able to draw a triangle? No. The focus is to be able to enlarge using a centre of enlargement. And so what we're going to do is we're going to take the drawing element out of it, make our life a bit easier here. So what we do is we provide the sheets, and I've got no problems with doing this at all. Bit of photocopying, but I think it does help here. So I look at the squares method first, and I do mention this stage. In an exam, yes, nearly every exam I've seen at GCSE will have a square background. It might be some axes on there as well, but it has a squared background. So this method is going to work very well here. Right. Okay, so we've got a scale factor of ×2. We saw with the bulb and the pencil that to have a ×2 means we're going to have it twice as big afterwards, but we have to do it relative to that centre of enlargement. Now, so what is the centre of enlargement? Well, think of it as the bulb. Think of it as the bulb before. What's going to happen here is that light is going to hit this triangle, and what it's going to do, we're trying to find out where the shadow is. Okay, so how much further must it be away? Well, we can always go back to that and say, obviously when it was 100 centimetres away and the image was had to be 200 centimetres away, we get an image that's twice as big. If we just pick that apart, we can say, well, let's think about it in a different way. If we want it to be twice as big, then we need the image to be twice as far away from the centre of enlargement than the object. Now, that's a mouthful, isn't it? But take your time to practice that, okay? Because it makes a difference. Every little bit of noise in the head when they're learning this can stop them getting a good grip of what's going on here. Right, so we're going to call this the object. We're going to have the image, i.e. the shadow. Okay, so how do we go about doing this? Central scale factor is ×2. We want the image to be twice as far away. The easiest way to do this with squares is to look at each point at a time. So what I'm going to do, I'm going to take point B, because it's the closest one. So how can I describe how far B is from O? What's the easiest way? Get them to give you that. Don't be there telling them all the answers we're going through here. Well, that's 2 units horizontally, 1 vertically. And again, horizontal, vertical, not along and up, right and up. Let's start getting that language all the time as we're going through this. So two horizontally to the right and 1 vertically up. Okay, so what we're going to do, we're going to times that by 2. Now, when I do this first, and I get them to do this with me. Okay, so I've got this in a printout, 2 and 1. I say, well, how far is the image going to be? Well, that's going to be twice as far. So it's going to be 4, 1, 2, 3, 4, and 2 up. And that's going to, I've chosen this on purpose. Look at that example. The image is actually going to fall. It's going to overlap the object, and this happens sometimes. So there's nothing to be worried about. What we're going to call that, even at this stage, let's start using the right terminology here. B dash. B dash. They say, why B dash? Because it's showing us that's the image. Repeat the C. 2, 4, 6. 6 across and 1 up. So we're going to be 12 across. So that's 6, 7, 8, 9, 10, 11, 12, and 2 up. Okay, so you can repeat this. And for A, it's going to be 2 across and 3 up. So we're going to go 4 across and 6 up. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And there we are. Make sure we do our labeling. Now, when I'm looking at the squares method, the same approach every single time I'm going to do this. Okay, so what we've got now is, now you can join it up. And what you're getting is enlargement. Now you can check, do the side lengths happen to be twice as large as the original side length? So this is the image. I'm going to label this. You can see B to C was 2, 4, and B dash C dash is 2, 4, 6, 8. So it works, doesn't it? We've got 8 there, we've got 4 there. Now it's worth pointing out, obviously, it's to get, to be doing it properly, an enlargement, having this triangle image enlargement, I should say this right, the triangle which is the image, okay, A dash, B dash, C dash, you could have that anywhere on the page. And that would still be an enlargement, but it wouldn't be an enlargement from this scale factor. And think about it, you know, if you're doing CGI or a game, the shadow has to appear in the right place. You can't just put it anywhere, and that's related to where the light is. I mean, you know, this sort of light source idea. And you can go into that as much as you like, really. Okay, what else can we check? Well, some of them say, well, hold on, do I need to do all three? You know, once they're confident with this, obviously, no, you get 1 point. You know the shape, so okay, it's got to be 8. We know it's going to be 8. We know that's going to be B dash D C dash could be 8, and A dash B dash would be 4. So you could draw the B dash and then straight away draw B dash to C, B dash to A, and then join up, and you'll get the triangle that way as well. Depends how well they're doing with this. Okay, we don't have to force them down that route of doing each point at a time if they grasp it really quickly. But I would definitely get maybe the first one. Just show me how you're doing it that way. So we can always fall back on this method. Finally, check it. So we're starting to bring in the ray method now. Check. You can draw these rays through. Look through A. Look where it ends up. Go through A dash. Now this is a moment of wonder, I think. Here. Allow me to do that. Yeah, there we go. B dash, look, and C, go through C. Where's it end up going through? C dash. Beautiful, isn't it? I mean, it does get a gasp sometimes. Well, yeah, look, it's like a cinema, isn't it? If you were watching a film about a triangle, a very boring film, the image would appear there. You can see those are the rays projecting that. That's the shadow that we're getting at A dash, B dash, C dash. Okay, so that's the sort of legwork of teaching that. Then I have examples. So I've got times 2, times 3, and you have to monitor them. But it's great. I usually ask them, look, when you've done 1, ask me to check so that I can see what they're doing and they do it correctly. Because sometimes they try to rush it and do the shortcut method and they make mistakes. So if that's the case, like I said, I would say with these ones, get them to do every point. It'd be much safer. Once they're confident, then they can, after this, they can move on to more tricky ones. Okay, fractional and negative scale factors. Sorry, going back to NASCAR again, sorry. So you can mention about this. I think it's nice to see where it is in the world that this is. And, some of them might have even been there if they're very, very fortunate. I haven't been there yet. But why I'm mentioning these, well, one of the theories of how they're created is in this way. A very small template or image of a spider or a condor was placed in one part of the desert, and then there's ropes or string or paces to make these Nazca lines. Each of those points was decided and then joined up to make these enlargements. Now, I don't know if it's true or not, but it would seem quite logical because these are massive. These are absolutely massive here. I don't know if they give the scale on this as well, but it's something you could look up when you're talking to them with them. And it might inspire them to travel as well. Okay, so yeah, in Peru, which is obviously in South America for us, but a lot of students won't know where that is in relation to where we are. Okay, fractional scale factors. What do they think is going to happen? We're going to use the same idea. Okay, counting horizontally and vertically. So I don't think I need to explain that anymore. But you can talk about the effect. What's happened with a fractional scale factor is that we get a reduction in size. So we're not going to use the word reduction. We're going to say an enlargement by a fractional scale factor, which is a bit strange, isn't it? Because you're not sure that that's actually what they would think of initially. Okay, ray method then. Once they're happy with that, then you can move on to the ray method, and they're going to need the rulers for that. So we can use measurement now, and through A, B, and C. So again, this is a training phase here. And so this is normally what I do with this, and then A, B, and C, and they'll measure, and we'll do the working down here. So, A, so we say for A, where are we? Let's have the pen here, shall we? So, so A, for A, we've got OA. So let's say OA is, I don't know, 4 centimeters. Then I would say OA dash has to be 4 times 3, which is 12 centimetres. Now, obviously, I said to you before about multiplication of fractions. These aren't going to come out nicely. It might be 4.2 times 3. And then when we get onto fractional scale factors, you're going to have to use a multiplication of fractions. And I would, if they have done multiplication of fractions, which they should have done by the time they've got to this, I would encourage them to do that working rather than let them use the calculator at this stage. But you may have to decide. Depends on what the set is. If they're just about grasping how to enlarge, then okay, let's just let them use the calculator for now, and we can always build that in a little bit later as an extension, because they're going to have to use multiple skills. Okay, Ray method. I have something like this. This is all training again. Something like this to check, and I can check these very quickly. And by the way, a good little hint here for checking visual or practical lessons is to get a bit of tracing paper. Make your own mark scheme with a tracing paper. Trace over it. Do your own enlargements. When you're checking them, you can overlay it. They can, and obviously, if you can't go into the student, you can actually leave this around. They can check it. They can pass it around and check it if you can't get close to those students. And then we've got negative scale factors here. Okay, so negative scale factors, you can count the same way. The negative obviously indicating that instead of, if it's as we would be here, OA would be, and I'm going to use left and up here, 2 left and 2 up. Okay, instead of going left and up, we're going to go right. We're going to move from the centre of enlargement right and down. And they see the effect of this. And I say it's like a bit like the object being sucked through the centre of enlargement, spat out the other side with that scale factor. Yeah, but these are all separate, probably a separate lesson anyway. So where do we go with this then? Okay, so I've got squared paper here. I've still got the back in here. I said use 10 points to enlarge Bart's head. So a bit like those Nazca lines, we're going to find 10 important points. Enlarge his head by minus -3/5. What would they expect to see? What would they expect to see? Describe, talk to your partner, and then share it with us. What do you think? What you're going to expect to see here? Once they've done that, you can change the image here, but I've done it based on confidence here. If they're really confident with this, I'd say, okay, let's go to a blank background. And I've chosen other images here. Now, these were done quite a while ago. So what you can do is actually, find more relevant images for now. Apologies for that beeping sound. I think that's my dinner burning. Yes, so you can use more relevant images. I mean, you can use whatever you like, really. You think whatever the class is interested in once you get to know those as well. So. And what have we got here? 3/5. I think I have one with a negative scale factor. That's 7/2. These ones I chose because the points are reasonably straightforward. But you can change the scale factor to whatever you want, and you move that around, print it out. You can call them red, one amber, one green. Here's a negative one here, so that I did before. One red, one amber, one green, and the students can select which one they think is most appropriate for them. Other alternatives to go off once they got happy with this, or once they've got happy with doing this, is you can use GeoGebra. I will be doing some videos on using GeoGebra. I've made a number of worksheets that I've used with classes using GeoGebra to explore maths. So there will be an enlargement one on there. But if you're an expert with that, that's a brilliant way in, because they can carry out enlargements in a very short space of time. The trick then comes about getting them to describe what's happening with those enlargements, and you could do it in a discovery type lesson where they're actually putting in these scale factors and seeing what the effect is. Okay, right. So I think that's enough for now. There will be another video about finding the centre of enlargement. I'll do another one on that. But in terms of using enlargement, carrying out an enlargement using a scale factor, I think I'm done for that one now. So I hope you found something useful. Go out there, be creative. Get and be creative and have fun. And thanks for watching, and I'll see you next time.